welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe it. I will continue the crash organic revision. So let's start. We have discussed three mechanisms like electrophilic addition, free radical substitution. We have discussed free radical substitution, electrophilic addition, and nucleophilic substitution. And we have discussed SN1, SN2 reaction. SN1 in 2 steps, slow and only one molecule, one reactant, haloalkane determine the rate of reaction. SN2 as tertiary haloalkane exhibit SN1 reaction, and SN2 reaction is going on in primary haloalkane and secondary haloalkane, and SN1 with secondary haloalkane as well. So, and SN2 takes place in 1 steps only. Okay. So today we will discuss elimination reaction. Elimination of haloalkane. This is haloalkane plus OH negative to form alkene plus X minus plus water. So mechanisms, reagent is sodium hydroxide or potassium hydroxide in ethanolic medium. Or ethanol used as a solvent. Temperature is heat under reflux, and OH ion act as a proton acceptor. So it accepts the hydrogen H positive loss from the halogenoalkane during elimination. And elimination is easier in primary than secondary and then primary, secondary and tertiary. So the mechanism is H, H, H. So this bond is going to break because this is electronegative, this is electropositive, this is electron withdrawing, and when this is OH, this is intermediate, this is carbocation, hydrogen and hydrogen. So this electron is transferred over here and this OH ion accept this proton. So this is intermediate and the compound is C double bond H, H and alkene is formed. So this is the elimination reaction, elimination of halogen on alkane. So next is hydroxy compound alcohols. Learning outcome, candidates should be able to recall the reaction, reagents, condition, conditions by which alcohols can be produced. So these are the methods in which alcohols can be produced. Electrophilic addition of steam to an alkene. H2O is the steam, H3PO4 catalyst and 60 atmospheric pressure. And H3PO4 catalyst 300 degree centigrade temperature. So electrophilic addition of steam to an alkene to form alcohol like this. Plus H2O under these conditions to form C2H5OH. Reaction of alkenes with cold acidified potassium manganate 7 to form diol. So this is the reaction like cold dilute acidified potassium manganate, C double bond hydrogen, hydrogen in the presence of cold acidified to form diol. H2 H2. So this is diol is formed. Substitution of haloalkanes using sodium hydroxide aqueous. So this is the nucleophilic substitution which in the presence of haloalkanes, so substitution of haloalkanes using sodium hydroxide and heat. CH3 CH2 X plus sodium hydroxide aqueous to form CH3 CH2 OH plus X minus and water. Substitution, this is also SN1 and SN2. By substitution of nucleophilic substitution of haloalkane using sodium hydroxide and heat, we get alcohol. Reduction of an aldehyde or ketone using NaBH4 and lithium aluminum tetrahydride is used as a reducing agent, so it converts ketone into alcohol, ketone into secondary alcohol and aldehyde in primary alcohol. Like for example, CH3 C double bond O CH3, addition of hydrogen to form CH3 in the presence of reducing agent NaBH4 or lithium aluminum tetrahydride to form CH3 CH OH. This is secondary alcohol. And if aldehyde is used, this is example of aldehyde, reaction of aldehyde. CH3 CH C, this is aldehyde, H NaBH4 or LiAlH4 in the presence of hydrogen is added to form CH3 CH2 OH. Sorry, yes, this is OH. This is primary alcohol. So aldehyde is going to primary alcohol and ketone to secondary alcohol. So next reaction is reduction of carboxylic acid using lithium aluminum hydrate. So reduction of carboxylic acid cannot take place in the presence of NaBH4. This is only takes place in the presence of lithium aluminum tetrahydride. So CH3 CH2 CO2H, and when we reduce this in the presence of hydrogen and LiAlH4 in dry ether, to form CH2 CH3 CH2 CH2OH. Propanol. Hydrolysis of an ester using dilute acid and dilute alkali. So this is also alcohol is formed in this reaction. Alcohol is also produced. For example, if this is ester CH3 CO2 CH2, CH3. So when we use sodium hydroxide plus water, it is CH3, CO2, Na plus ethanol, CH2, CH3, CH2, OH. This is alkaline hydrolysis. And acidic hydrolysis also gives alcohol. For example, HCl plus water to form CH3CO2H, carboxylic acid plus ethanol. So these are the reactions in which alcohol is formed, or making alcohol from these methods. Describe the reaction with oxygen combustion. Alcohol also there is complete and incomplete combustion. Complete combustion gives carbon dioxide and water. Incomplete combustion, carbon monoxide and water. So this is incomplete and this is for complete combustion. Substitution to haloalkanes by reaction with HX or KBr with H2SO4 or H3PO4 or PCl3 heat with PCl5 so Cl2. I have discussed earlier in haloalkane about these reactions. So haloalkanes are formed by reacting alcohol with PCl3, PCl5 and SOCl2 to form halogenoalkane. So HX or KBr with H2SO4 like KBr when react with sulfuric acid form KHSO4 and HBr. This HBr further react with CH3 CH2OH plus HBr to form CH3 CH2 Br and H2O. This is for bromoalkane and for iodoalkane. This method is used to producing haloalkane, and this phosphoric acid is also used in this method. For example, KBr react with H3PO4 to form KH2PO4 plus HBr. So this HBr react with alcohol to form haloalkane CH3 CH2 Br plus water. So next reaction is reaction with sodium. This is confirmatory test of the alcohol when we react with alcohol C2H5 OH plus sodium to form C2H5ONa plus H2. So oxidation of with acidified potassium dichromate or acidified potassium manganate, CH3 CH2 OH to form CH3 CO2 AH in the presence of acidified potassium manganate, acidified potassium dichromate, and the observation is purple to colorless, or in this case orange to green. You know that primary alcohol form carboxylic acid, secondary alcohol to form ketone which is not further oxidized, and tertiary alcohol resist oxidation. Carbonyl compounds by distillation. If acidified potassium dichromate first changes into CH3, CH2, OH to form CH3, CHO, and then CH3, CO2H. If distilled immediately, then we get aldehyde. If not, then it is oxidized into carboxylic acid. So, but secondary alcohol changes into ketones, which is not further oxidized. Carbonyl compounds by distillation, we can separate carbonyl compounds by distillation. Carboxylic acid by refluxing. So, distilled to get aldehyde, if not, then carboxylic acid. This is refluxing. If refluxing, there carboxylic acid is formed. If distillation, then aldehyde is also formed. Primary alcohol give aldehyde, which can be further oxidized to carboxylic acid. Secondary alcohol give ketones. Tertiary alcohols cannot be oxidized. Dehydration to an alkene by using a heated catalase, aluminum oxide or concentrated acid to form So the formation of esters by reaction, dehydration of alkene by using heated catalyst, aluminum oxide or concentrated acid. So, and this is formation of esters by reaction with carboxylic acid and concentrated sulfuric acid and phosphoric acid as a catalyst. This is the reaction. Classify alcohol as primary, secondary and tertiary alcohols to include examples with more than one alcohol group. This is primary alcohol, and this is secondary alcohol, that alcohol attached with the carbon atom which is bonded with one hydrogen atom. So over here primary alcohol, alcohol attached with carbon atom of alkyl group which is bonded with two hydrogen atom, and over here with no hydrogen atom, the alcohol attached with carbon atom which has no hydrogen atom. This is tertiary alcohol. State characteristic distinguishing reaction: mild oxidation with potassium, acidified potassium dichromate, color change from orange to green, first changes into aldehyde, then changes into carboxylic acid. And if there is secondary alcohol, changes into ketones and color change would be orange to green. Now deduce the presence of CH3CHOH group in an alcohol. Form its reaction with alkaline iodine to form yellow precipitates of triiodomethane, and an RCO2 negative ion is formed. So this is the triiodomethane. Test takes place with the CH3 OH CH2. So if the compound is OH is attached with this carbon is directly attached with CH3, this will give triiodomethane. CH3 yellow precipitate is formed, and this compound is converted into CO2 negative, or if like this CH3 OH, and this is R group, and carrying this. This also gives triiodomethane. Secondary alcohol also gives triiodide. If CH3 is directly attached over here, if CH3 is attached with this also gives triiodomethane test. CHI3 yellow precipitate of methyl uh, tetraiodide and plus R CO2 negative. Explain the acidity of alcohol compared with water. Explain the acidity of alcohols with water. This is example of HOH. This is example of CH3 CH2 OH. This is partial negative, this is partial positive, on both sides partial positive, and this is carbon partial and this is partial negative. So alkyl is electron withdrawing group, electron donating group. So electron donates, which make this bond stronger, OH bond stronger, electron donating effect which make this bond stronger and difficult to dissociate. But over here no alkyl group, so it is easily. But alcohol can vary in acidity depending on the type. For instance, ethanol, the type of alcohol found in beverages, is slightly acidic with pH around 6 to 7.4. This makes it slightly less acidic than water, but it is less acidic than water. But if we compare methanol, so methanol can be more acidic than water because less alkyl group is there, CH3OH. So ethanol, as the carbon chain is going to increase in the alcohol, so it will become less acidic than water. But in case of methanol is more acidic than water, and ethanol is less acidic than water. Next is the carbonyl compounds. Aldehyde, recall the reaction reagents and conditions by which aldehydes and ketones can be produced. We have earlier discussed about how aldehyde and ketones are produced. Now, oxidation of primary alcohol using acidified potassium dichromate, acidified potassium manganate, and distillation to produce aldehyde. If distilled, we get aldehyde. If not distilled, changes into carboxylic acid. Similarly, the oxidation of secondary alcohol using acidified potassium dichromate, acidified potassium manganate, distills to produce ketones. I have earlier discussed this reaction. Describe the reduction of aldehydes and ketone using NaBH4, lithium aluminum tetrahydride to produce alcohols. Primary alcohol gives aldehyde gives primary alcohol, while ketones give secondary alcohol. So this is how to get primary and secondary alcohol from aldehyde and ketones. I have discussed earlier this reaction. The reaction of aldehyde and ketones with HCN, KCN as a catalyst and heat to produce hydroxynitrile, exemplified by the ethanol and propanol. So this is the reaction which I will discuss with you, the reaction of aldehyde and ketones with HCN and KCN as a catalyst and heat to produce hydroxynitriles. Describe the mechanism of the nucleophilic addition, reactions of hydrogen cyanide with aldehyde and ketones. Use of 2,4-dinitrophenyl hydrazine. Next mechanism is nucleophilic addition. addition. Reagent is HCN, and conditions HCN with alkali or HCN with KCN. Type of reaction is nucleophilic addition. The product formed is hydroxynitrile, or it is known as cyanohydrin. Or cyanohydrin. Aldehydes are more susceptible to nucleophilic attacks than ketones. More minor carbonyl compounds are more reactive. A product has a chiral carbon, exhibits optical isomers. So this is the mechanism. This is R group, double bond O. This is aldehyde carrying partial positive. CN partial negative. And this electrons to form H positive and CN negative, and this CN negative to form HCr CnO. Carrying negative, and this H positive to form HCr OH and CN. This is cyanohydrin. Please keep it in mind that HCN is a poor nucleophile. HCN is a poor nucleophile or weak nucleophile. With few cyanide ions, the reaction is slow. To increase concentration of CN, make HCN react in the presence of alkali. presence of sodium hydroxide. So HCN plus OH negative to form H2O plus Cn negative. So this reaction makes cyanide ions more in this reaction. So this is the mechanism. This is very important mechanism. Please learn this mechanism by heart, especially curly arrows and charges and electrons. So 2,4-dinitro, describe the use of 2,4-dinitrophenylhydrazine to detect the presence of carbonyl group. Describe the use of 2,4-dinitrophenylhydrazine is a confirmatory test of the carbonyl compounds, and any compounds like this is carbonyl compounds, C double bond O, react with 2,4-dinitrophenylhydrazine H. This is 2,4-dinitrophenylhydrazine. Over here nitro group, over here nitro group. So this is formed like this. Water is formed. This is formed water plus C directly bonded with NH, and this gives, if orange precipitates are formed, then carbonyl compound is present. If not, carbonyl compound is absent in the given, and this is known as 2,4-dinitrophenylhydrazone. Hydrazone. Deduce the nature of aldehyde or unknown carbonyl compound from the simple test Tollern reagents, and Tollern reagents is a mild oxidizing agent, and this will confirm that whether aldehyde or ketone is present in the carbonyl compound. So if silver mirror or gray black precipitates are formed, then it identifies that it is aldehyde. If no change, then that is the ketones. So this is the test of aldehyde solution of carbonyl compound form. A simple test of failing reagents, ease of oxidation. So this is the only test that is Tollern reagents. And Tollern reagent is the solution of, this is solution of AgNO3 twice plus NH3 excess. In this reaction, 2Ag positive plus RCHO2 to form Ag solid plus RCOH. This is mild oxidizing agent. So this is Tollern reagent, and this gives silver mirror test. And failing solution also gives red precipitates if react with copper sulfate in ammonia solution. This is silver mirror test, and this is going to identify in the P3 as well, and failing solution is copper sulfate in plus ammonia solution, and aldehyde is get reduced Cu2 positive plus RCHO to form 2Cu positive gives red precipitate plus RCOOH. So this compound, this is the failing solution. Tolan reagent and failing solution confirm that aldehyde is present. So again, try iodomethane test with the ethanol in case of CH3 C double bond. This gives try iodomethane test only this. In case of aldehyde ethanol, but in case of if CH3 is directly bonded with that carbon which is bonded with oxygen atom, this gives triiodomethane test and gives yellow precipitate. Next is the carboxylic acid. Recall the reaction by which carboxylic acid can be produced: oxidation of primary alcohol and aldehyde with acidified potassium dichromate and acidified potassium manganate and refluxing. Hydrolysis of nitriles with dilute acids or dilute alkali. For example, RCOH, CN, CH3. This gives RCOH, CO2, CN gives CO2H and CH3. So this is also very important reaction. Nitrile is hydrolyzed to form carboxylic acid. Hydrolysis of esters with dilute acid I have earlier discussed, and heat followed by the acidification. Describe the redox reaction with reactive metals. This is the carboxylic acid properties. Reactive metals like sodium, potassium, magnesium react with carboxylic acid to form salt and hydrogen gas. The neutralization reaction with alkali to produce a salt and water, and the acid-base reaction with carbonates to produce salt, water and carbon dioxide. Esterification with alcohols with concentrated sulfuric acid as a catalyst. Reduction of lithium aluminum tetrahydride from primary alcohol. I have earlier discussed this point also. Esters learning outcome. In case of ester, recall the reaction reagents conditions by which esters can be produced. The condensation reaction between alcohol and carboxylic acid. The reaction is condensation. Please don't write esterification, write down condensation. Alcohol and carboxylic acid, CH3 C2H5OH plus CH3 CO2H to form CON. This is reversible reaction. H2SO4 to form ethyl ethanoate. C2H5. Describe the hydrolysis of esters by dilute acid and by dilute alkali and heat. Nitrogen compound primary amines. Recall the reaction by which amines can be produced. Reaction of haloalkanes RX plus ammonia in ethanolic medium gives RNH2. Reaction of haloalkanes with NH3 in ethanol heated under pressure. High pressure and heat under high pressure. Classification of amines will not be tested at AS level. Nitriles and hydroxynitriles. Recall the reaction of by which nitriles can be produced. nucleophilic substitution, reaction of halogenoalkane with KCN I have discussed earlier in ethanol, and heat. Recall the reaction by which hydroxynitriles can be produced. The reaction of aldehyde and ketones with HCN and KCN discussed earlier as catalyst and heat. Describe the hydrolysis of nitriles with dilute acids and dilute alkali followed by acidification to produce carboxylic acid. Polymerization I have discussed earlier about the addition polymerization, in which polyethene and polychloroethene I have discussed earlier and their uses as well. Deduce the repeat unit of addition polymer obtained from the given I discussed earlier in alkene. Identify the monomers present in a given section of an addition polymer molecule. Recognize the difficulty of the disposal of polyalkenes, non-biodegradable and harmful combustion products. So landfill sites and harmful products like HCl and HCN gases are produced which are toxic. So these are the addition polymerization. Organic synthesis, you know that different routes of formation of different compounds should be known by the should be known with the mechanism as well as with the reagents. Identify organic functional groups using the reactions in the syllabus. Predict properties and reactions. Devise multi-step synthetic routes for preparing organic molecules using the reaction in the syllabus. Analyze a given synthetic route in terms of type of reaction, reagent used for each. For example, if there is alkene CH3 CH2 CH So if this compound is given, so carboxylic acid is the final product, then you should know the route of forming carboxylic acid. So this is alkene, and alkene changes into carboxylic acid, and which reagent, which conditions are required over here and which conditions are reagents are required over here. This is cracking and over here oxidation with the acidified potassium magnate. So different formation of different organic products are required, and you should know their reagents and their conditions, different conditions. For example, like if this route is required, CH3 CH2OH CH3 CH2Cl CH3 CH2Cn and this is CH3 CH2NH2. This is changes into CH3 CH CH2 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 CH2, and this is again changes into CH. So this alcohol also converted into alkene, and this is changes into haloalkane changes into alkene. So this is changes into amine, haloalkane changes into amine, and haloalkane changes into nitrile, and nitrile changes into carboxylic acid CH3 CH2 CO2H. So how this conversion takes place, you should know the reagents and type of reaction over here. For example, this is elimination reaction, this is nucleophilic substitution, this is also nucleophilic substitution, this is also nucleophilic substitution, this is also elimination reaction and this is hydrolysis reaction. You should know the types of reaction and their reagents and condition as well. Hopefully you understood all these reagents with syllabus contents, and happy revision with this syllabus contents by watching this video.